In the vastness of the universe, beyond the veil of our blue sky, lies a realm so immense, so ancient, it defies comprehension. Billions of galaxies swirl in the darkness, each home to stars, planets, and perhaps stories like ours. Among them, spinning like a giant celestial pinwheel, is our galaxy, the Milky Way. And within one of its spiral arms, we find ourselves, a small solar system orbiting an average star, on the edge of a cosmic sea. The Milky Way, a name that evokes wonder. A galaxy so vast that light takes over 100,000 years to cross from one side to the other. From Earth, it appears as a milky band stretched across the night sky, a ribbon of stars too numerous to count. But that shimmering band is only a small piece of a grander structure. The Milky Way is a barred spiral galaxy, its arms gracefully swirling outward from a dense central bulge. Within its core lies a hidden giant, Sagittarius A, a supermassive black hole, with a mass over 4 million times that of our Sun. It is invisible to the eye, yet its gravitational influence binds the galaxy together. Our solar system is situated in a quiet suburb of this cosmic city, within the Orion Arm, about 27,000 light-years from the galactic center. And as the galaxy spins, so do we, orbiting the center once every 225 million years. This journey is known as a galactic year. The last time Earth was in this part of the galaxy, dinosaurs roamed our planet. Around 4.6 billion years ago, a massive cloud of gas and dust, disturbed perhaps by a nearby supernova, began to collapse under the force of gravity. As it spun and flattened into a disk, matter collected at the center, igniting nuclear fusion and forming a star, our Sun. Around it, debris collided, merged, and formed the planets, moons, asteroids, and comets that would become our solar system. What emerged was a complex family of worlds, each unique, each following its own path around the star that gave it life. At the heart of the solar system burns the Sun, a glowing sphere of hydrogen and helium, 1.3 million times the volume of Earth. It provides light, warmth, and the energy needed for life. Deep within its core, atomic nuclei collide in a dance of fusion, producing the light that takes thousands of years to reach the surface, and just 8 minutes to reach Earth. The Sun's gravity dominates the solar system, keeping planets, moons, asteroids, and comets in their steady orbits. But it is not a quiet star. Sunspots, solar flares, and coronal mass ejections send waves of energy out into space, influencing space weather and sometimes disrupting our own technology. Closest to the Sun are the 4 inner planets, small, dense, and rocky. Each tells a story of heat, atmosphere, and change. Mercury, the smallest and closest to the Sun, is a scorched and cratered world. With virtually no atmosphere, temperatures swing from freezing to burning in a single day. Venus, wrapped in a thick veil of carbon dioxide, traps heat in a runaway greenhouse effect. It is the hottest planet in the solar system, a place where lead would melt and sulfuric acid rains from the skies. Earth, our only known oasis. A delicate balance of atmosphere, water, and temperature makes life not only possible, but abundant. Oceans cover over 70% of its surface, and the magnetic field protects us from solar winds. It is, for now, the only known world to harbor life. And then, Mars, the red planet. Once flowing with rivers and lakes, today it is dry and cold, but not without mystery. With polar ice caps, massive dust storms, and evidence of ancient water, Mars remains a target of exploration and imagination. Between Mars and Jupiter lies a vast region of rocky debris, the asteroid belt. These are fragments that never coalesced into a planet, pulled and tugged by Jupiter's powerful gravity. Among them are objects like Ceres and Vesta, silent witnesses to the early days of the solar system. Beyond the asteroid belt, the solar system changes dramatically. The gas and ice giants reign here, massive worlds with dozens of moons and powerful weather systems. Jupiter, the largest planet, is a colossus of hydrogen and helium. With a storm larger than Earth, the Great Red Spot, and over 90 moons, Jupiter is like a solar system within a solar system. One of its moons, Europa, may harbor a subsurface ocean beneath its icy crust, a potential cradle for life. Saturn, with its iconic rings, is a planet of beauty and complexity. Its moon Titan possesses lakes and rivers, not of water, but of liquid methane. And Enceladus, another icy moon, shoots water vapor into space, suggesting an ocean below. Further out, Uranus spins on its side, the only planet to do so. A pale blue world with faint rings and a frigid atmosphere. Then comes Neptune, deep blue and dynamic, home to the fastest winds in the solar system. Its moon Triton orbits backward, hinting it may be a captured object from beyond. As we gaze deep into the night, through telescopes that stretch our vision across time and space, we realize the light we see from distant stars left its source long before humanity learned to write. Every glimmer in the sky is a message from the past, some from stars that no longer exist. And yet, from this pale blue dot, we have come to understand so much. We've decoded the elements that make up stars. We've measured the speed at which galaxies drift apart. We've sent machines into the void, carrying our hopes, our science, even our music. Voyager 1, launched in 1977, now travels through interstellar space, farther than any human-made object has ever gone. On board, a golden record carries greetings in dozens of languages, sounds of Earth, and a map to our home. Should it ever be found, it tells a story not just of where we are, but of who we are. We are the universe becoming aware of itself, stardust with consciousness. The atoms that form our bodies were forged in ancient stars. When they died, they scattered their elements across space. From that cosmic debris, new stars formed, and planets, and life. In a very real sense, we are children of the Milky Way, born from its elements, shaped by its forces, wandering through its arms. What lies ahead for our species is unwritten. But one thing is certain: our curiosity will not rest. Humans will walk on Mars. We will build outposts on the Moon. We may one day sail the oceans of Europa, or fly through the skies of Titan. New telescopes, like the James Webb Space Telescope and the upcoming Roman Space Telescope, are already reshaping our understanding of the universe. They peer back to the earliest moments after the Big Bang, and forward to the formation of distant worlds. With every discovery, we ask deeper questions. Are we alone? How rare is life? Is there another world like ours, a twin Earth orbiting a distant sun? We are only one solar system in a galaxy of hundreds of billions. And this galaxy is but one among trillions. The scale is beyond comprehension. Yet still, here we are, dreaming, wondering, reaching. When you next look up into the night sky, remember, you are not looking at emptiness. You are looking into a living, breathing story, one of gravity, light, time, and evolution. A story that includes stars being born, planets swirling in dance, and galaxies colliding in slow cosmic ballet. And within that story is us. We are the astronomers and explorers. the mathematicians and poets. We name the stars, we send ships to touch them, and we write songs about their beauty. Our place in the cosmos is humble, but our reach is vast. And as long as we continue to explore, with wonder in our eyes and science in our hands, the universe will never be a stranger. To the stars we go, not to escape Earth, but to better understand it. Not out of fear, but out of wonder. And always in search of our place in the story of the stars. Beyond the comforting warmth of our own sun, and past the icy boundaries of our solar system, lies an ocean of stars. Each point of light in the night sky is not just a star. It is a sun. And many of them, we now know, are home to planets, alien worlds that orbit distant stars, unknown and unseen for most of human history. For centuries we wondered, were we alone in having a solar system? Now, we know we are not. In the last few decades, science has confirmed the existence of thousands of exoplanets, planets orbiting stars beyond our sun. Some are hot and enormous, others are frozen and small. Some orbit twin suns, others dance in tight orbits so close they complete a year in just hours. Our Milky Way contains over 100 billion stars, and possibly more. Each one is unique, a nuclear furnace fueled by fusion, radiating energy into the void. Some are young and massive, burning bright and dying fast. Others are small and steady, living for trillions of years. There are red dwarfs, the most common stars in the galaxy, small, cool, and long-lived. Then there are yellow dwarfs like our Sun, stable and hospitable. Some stars expand into red giants as they age, eventually shedding their outer layers. The most massive stars end in spectacular explosions, supernovae, forging heavy elements in the process, seeding the galaxy with the building blocks of life. Even more exotic are neutron stars, ultra-dense remnants of collapsed giants, and black holes, where gravity becomes so strong that not even light can escape. These are the extremes of stellar evolution, and they remind us of the power and fragility of stars. The first confirmed exoplanet was discovered in the 1990s. Since then, we've found over 5,000, and the number grows every year. Thanks to telescopes like Kepler and TESS, and soon Plato and the James Webb Space Telescope, we're beginning to catalog the architecture of other planetary systems. Some planets are gas giants like Jupiter, orbiting extremely close to their stars. We call them hot Jupiters. Others are super-Earths, rocky worlds larger than Earth but smaller than Neptune. And some lie in the habitable zone, not too hot, not too cold, where liquid water could exist. One of the most fascinating systems discovered is TRAPPIST-1, a red dwarf star with 7 rocky planets, 3 of which are in the habitable zone. These planets orbit so close to each other that if you stood on one, you might see the others hanging in the sky, large as moons. Each exoplanet brings new questions. Could life exist there? Is there an atmosphere? Does it rain? Could there be oceans, continents, or even civilizations we cannot yet imagine? Not all stars shine alone. Many exist in binary or trinary systems, where 2 or more stars orbit a common center of gravity. Planets in these systems must navigate a complex gravitational dance. Some orbit just one of the stars, others orbit both in wide loops, like the planet Tatooine from science fiction. There are also rogue planets, lonely worlds flung out of their star systems, drifting through the darkness of interstellar space. No sun, no day, just endless night. warmed only by the heat left from their birth. And in some cases, we find planets where the laws of nature seem bent. Gas giants so close to their stars they are being vaporized. Rocky planets covered in lava, tidally locked, so one side burns while the other freezes. Even worlds made of diamond or covered in clouds of glass. We search the skies not just for planets, but for signs of life. The James Webb Space Telescope now allows us to analyze the atmospheres of distant worlds. By studying how starlight passes through a planet's atmosphere, we can detect the presence of gases, like water vapor, methane, or oxygen, that might hint at biological processes. We call this the search for biosignatures, and though we have yet to find definitive proof, we are closer than ever before. Could microbial life be common, scattered across the galaxy in warm oceans and icy caves? Could intelligent civilizations have risen and fallen long before Earth even formed? The universe is old. The possibilities are endless. We stand at the edge of a great era. Robotic missions to the outer solar system continue. Space telescopes are growing more powerful. Private companies are designing interstellar probes. Scientists even dream of sending light-sail spacecraft to Alpha Centauri, our nearest stellar neighbor, to arrive within a human lifetime. The more we learn, the more profound our questions become. What is the nature of life? How rare is intelligence? Could the laws of physics allow for faster-than-light travel one day? These questions drive our curiosity. They shape our technology. They define our future. Each star is a note in the grand symphony of the galaxy. Each planet is a verse in a cosmic poem, telling of fire, ice, storm, silence, and perhaps life. As we chart these distant systems, we are not just explorers, we are listeners, tuning into a conversation that began long before us and will continue long after we're gone. The stars have always been our compass, for sailors, dreamers, and now, scientists. They guide us, not just across oceans, but across epochs. And though we have only just begun this journey into the galaxy's heart, we carry with us the most powerful tools of all: imagination and the will to know. Out there, in the darkness between stars, there are other worlds. And on one of them, perhaps another version of us looks to the sky and wonders if they are alone. Some of the stars we see in the night sky may already be gone, their light traveling across the abyss for hundreds, thousands, even millions of years before finally reaching us. In this way, the night sky is a time machine. Every twinkle is ancient history, written in photons. And yet, what of the stars we cannot see? There are billions more, veiled behind clouds of dust, hidden in distant galaxies, or simply too faint to be detected. These stars and the planets that orbit them are waiting for better tools, for clearer eyes, for the next generation of seekers to bring them into focus. In our search for other life, we listen. We point radio telescopes at the sky. We scan for patterns, pulses, signals that cannot be explained by nature alone. But so far, silence. This absence has a name: the Fermi paradox. With so many stars, so many planets, and so much time, where is everyone? Why haven't we heard anything yet? Perhaps intelligent life is incredibly rare. Perhaps civilizations rise and fall quickly, their signals flickering for only a cosmic moment. Or perhaps they're out there, watching us, waiting for us to reach a level of understanding we haven't yet achieved. The silence, rather than being a disappointment, is part of the beauty. It means the story isn't finished. It means we're early, or that the universe is more mysterious than we dared to believe. The universe doesn't need us to observe it, but we are here, and we do. We ask questions. We build machines to look deeper. We launch telescopes, scan wavelengths, map dark matter. We imagine what it would feel like to walk beneath another sun, to watch twin moons rise above an alien sea, to breathe in the thin, crisp air of a new world. We wonder what colors the skies of other planets might be. We ask what music might sound like on a world with no air, or if a civilization could evolve beneath an ocean of methane. And in this wondering is something sacred, because every star we see and every world we find isn't just a discovery. It's a reminder that we are part of this, that the atoms in our bodies are cousins to the atoms in distant suns, that the story of the stars is also the story of us. In the cosmic scale, we are newcomers. The universe is 13.8 billion years old. Humanity, as we know it, has existed for only a fraction of a second on that scale. And yet, in that brief moment, we've reached beyond our world. We've seen the invisible. We've dreamed the impossible. This is just the beginning. We will build greater telescopes, travel further than ever, and perhaps, one day, set foot on worlds that today exist only as numbers in a database. With each new world, each strange sun, we step further into the unknown and closer to understanding who we truly are. The stars were here before us. They will remain long after us. But while we are here, let us look up and listen and reach. Because out there, among the stars, is our future. As we move farther still, we reach the icy outskirts, the Kuiper Belt. Here lies Pluto, once considered the ninth planet, now classified as a dwarf planet. Its surface is covered in nitrogen ice, and it has a thin atmosphere that freezes and falls to the ground as it moves farther from the sun. Other dwarf planets, like Eris, Haumea, and Makemake, inhabit this distant region, orbiting in slow, elliptical paths. Farther still, in the cold darkness where the sun is little more than a bright star, lies the hypothetical Oort cloud, a spherical shell of icy bodies and the source of many long-period comets. It may mark the boundary between our solar system and interstellar space. Our understanding of the solar system has grown through centuries of observation, theory, and exploration. From Galileo's first glimpse of Jupiter's moons, to robotic missions like Voyager, Cassini, and New Horizons, to telescopes orbiting above Earth, we continue to uncover the secrets of our cosmic neighborhood. And yet, we have only just begun. New missions aim to land on Europa, return samples from Mars, and even explore asteroids. Telescopes search for planets around other stars and signs of life beyond our solar system. The Milky Way continues to turn. Stars are born and die. Planets drift through the void. And here we are, on a fragile world, orbiting a modest star, on the edge of a galaxy filled with possibilities. As we look to the skies, we are reminded of our smallness, but also our potential. In the silence of space, there is a story waiting to be told. And we are the storytellers, the explorers, the dreamers. This is our home. This is our solar system. This is the Milky Way.